So I think we can start. Good morning to all of you, ladies and gentlemen. I'm Marta Debolini, and I will chair this webinar. We'll be talking about plant oils and their contribution to climate change. This webinar will be held by Maria Vincenza Chiriacò. By way of introduction, let me briefly talk about CMCC, our institute. CMCC is an international research center that studies the interaction between climate change and society. Quite clearly, it considers, in so doing, the analysis from different viewpoints, and most especially in relation to the different disciplines, so that we can develop adaptation and mitigation policies which are based upon scientific knowledge. So the main mission of the Institute is to develop quantitative analysis and forecasts based upon climate scenarios. The Institute is organized around 3 research institutes, and they are different, most especially based upon the topics that they delve into. We have a highly multidisciplinary environment. There are 3 research institutes, one for the Earth forecast, the other one is for climate resilience, and then we have the European Institute on the Economics and Environment. On top of that, CMCC, how shall I say, has a super processing center in Lecce. It was launched in 2008, and it is the largest in Italy and amongst the most advanced in Europe, and it is exclusively devoted to climate change research. The CMCC Foundation has several offices. It's a network, a distributed network based in several Italian cities. We have offices in Milan, Venezia, Bologna, Sassari, Viterbo, Caserta, and Lecce. The administrative office, which is the heart, is in Lecce. And the network is also based on a number of institutional partners, which are the ones that initially gave life to CMCC. That is to say, Istituto Nazionale di Geofisica e Vulcanologia, Università del Salento, Università Ca' Foscari di Venezia, UNIS, Università della Turcia, Politecnico di Milano, Università di Bologna, and Resources for the Future. So here we are to today's webinar. Quite clearly, the audio and video of the participants are off. And likewise, we've deactivated the chat, but if you have any questions and answers, you can use the dedicated questions and answers tab. It's on the Zoom bottom. And so after the presentation of Maria Vincenza Chiriacò, we will take any questions that you might have. So use the dedicated questions and answers box to write your questions. Maria Vincenza Chiriacò is a researcher of the Institute for Climate Resilience, and in particular, she belongs to the IAPES division, which is the one that analyzes the impacts of climate change on agriculture, forests, and the ecosystems and their services. Thank you, Marta. Let me first share my presentation. Can you confirm you can see it? Asks the speaker. Yes, we can see it. Now it's full screen. Okay, off we go. Thank you. And like you said, Marta, today we'll be talking about plant oils and their contribution to climate change. So on this slide, I will try and give you a brief overview of emissions globally in particular from the agro-food system. This is a chart produced by the IPCC. It was produced in 2022 in the IPCC AR6, and it tells us that global emissions every year are about 59 gigatons of CO2 equivalent, and you can see the colored bar. It shows the breakdown of the emissions based upon the sectors they come from. Interestingly, the AFOLU, agriculture, forestry, and other land use, accounts for 22% of the global emissions, and so almost like the industry and electricity sectors. So the sector in which we manage our lands, including agriculture and deforestation for the production of produce. This AFOLU sector has a big impact in terms of greenhouse gases emissions and in causing climate change. But even more interestingly, this IPCC report tells us that these emissions, i.e. 22% of these emissions, can go up to 42% of the global emissions if we consider the whole global agro-food system. So besides the production in the field of our food, if we add transport, industry, and energy, well, this is how we get food on our tables every day. So since this accounts for 42% of the global emissions, the food system is the main cause of climate change globally. In addition, the absolute value of the emissions moved from 14 to 17 gigatons of CO2 equivalent from 1990 to today. So this brief introduction shows that agricultural production as well as food processing must become more sustainable if we want to somehow come to terms with the climate crisis. So moving to today's topic. Today we are talking about plant oils, which exceed the production of over 200 millions of tons per year globally. And the main ones are palm oil, 36%, and palm kernel oil. They both come from oil palm, and the crushing of the fruit, the soft part of the fruit, and palm oil accounts for 4% of the global production, and it comes from the crushing of the seeds. Palm oil is followed by soybean oil, 28% of the global production, and then rapeseed oil, 12%, and sunflower, 9%. So these four oils, 5, including palm kernel, account for 80% of the global production of plant oils. And then there are others, including olive oil, for example, that we know very well in the Mediterranean diet, but they only account for small proportions of the total. Some of these oil crops are amongst the main drivers of deforestation globally, and in particular, oil palm and soybean, for example. So in particular, if you take a look at palm oil, we've said that it certainly is the most widely used in the world amongst plant oils, but it's been hardly criticated because of the deforestation in the primary tropical areas as a result of the expansion of palm oil plantations, most especially in Malaysia and Indonesia. So this criticism that we have seen of the last few years, most especially in the agro-food field, so in using palm oil for food reasons, led to two different answers from the main players in the agro-food sector. So on the one hand, some producers have chosen to replace palm oil, most especially in their recipes and agro-food products, replacing it with the oils which are more widely present and available globally and that can be potential replacements of palm oil. So soybean, rapeseed, and sunflower, which are widely available and also have organoleptic characteristics that are similar and they are edible, and so they can potentially replace palm oil. Other players instead in the agri-food sector have decided to continue to produce and use in the recipes of their products the palm oil, but focusing on the possibility of using certified deforestation-free palm oil. So they've ensured through certification schemes which exist globally, like the RSPO, that is a global certification of the sustainability of palm oil. So they've certified this palm oil as coming from deforestation-free supply chains, which ensure that there has not been any deforestation for production. So these plantations historically and recently over the last few decades have occupied agricultural area and so have caused no deforestation at the time. That was the background, and we've carried out a study to understand which is the best solution. On the one hand, deforestation-free palm oil, or replace palm oil with other edible plant oils, the ones I mentioned before. Well, the study is on the environmental impact of these two choices, analyzing the risk of deforestation and the total GHG emissions. So this is the study that was recently published on Science of the Total Environment, which is an international peer-reviewed journal that is available as an open access online. So it's possible to download it and read it. So what have we done in this study? Well, the idea was to identify what could be the areas of production available in different countries as part of a number of scenarios. So on the one hand, we have considered the production of deforestation-free palm oil, and on the other hand, we have assumed replacement scenarios to replace palm oil on different levels, like 25% of the current global consumption, or 50%, or even 100% of replacement. So 3 tiers of replacement, including the disappearance of palm oil from the food sector, replacing it with a mix of the 3 oils, soybean, rapeseed, and sunflower, each analyzed in the 3 main countries in which it is produced. Like, for example, in the case of soybean, we've considered Brazil, the USA, and Argentina. In the case of rapeseed, Canada, China, and India. In the case of sunflower, Russia, Ukraine, and Argentina. And Argentina, as you can see, is a leader in the production of 2 plant oils, rapeseed and sunflower oils. So we've used data set available globally, like FAO stat data set, and we've seen the amounts of oil to be replaced or implemented. In the 25% scenario, we've assumed to replace 25% of the current consumption of palm oil, i.e. 21 million tons. In the 50% scenario, we've assumed the replacement of 42 million tons, and in the 100% scenario, we assume the complete replacement of palm oil, i.e. 84 million tons, roughly. And this was breakdown for the various oils and countries of production. We've calculated the exact quantities that should be produced in addition, considering the current breakdown of the various oils in the various countries. And in the other columns, we've also calculated the area necessary, the additional area necessary in each of these countries in order to meet this need to replace 25, 50, and 100% of palm oil with these oils. Like we need about 32 million hectares more as compared to the existing crops. So we need 32 more hectares, and 64 in the 50% scenario, and 128 million hectares more to fully replace palm oil. quite clearly in replacing palm oil. We also have surfaces which are freed up in Malaysia and Indonesia. They would be freed up in the case of discontinuance of palm oil production, but we wanted to see where in the 8 countries these areas are. And to do that, we have developed an algorithm of expansion, the GIS, analyzing different data sets existing globally. The GIS, a geographic information system that aggregates space-based information. The algorithm was forwarded to each country, and it's based on exclusion, inclusion, and prioritization criteria. The exclusion criteria related to the areas that we believe are not available for the expansion of oil crops in order to meet the requirements of the scenarios, and amongst these there are protected areas, so they are excluded from the possibility of being used. We've also excluded indigenous lands, i.e. the lands, most especially in Southern America, they are protected for the local indigenous communities. So in that case, we have excluded them in order to prevent a change of use in the soil. And then we've excluded areas harvested with the target oilseed crop. And finally, we have excluded the areas with a low suitability for the target oilseed crop, mainly due to climate parameters. For example, in the case of soybean, if the models used, in this case, we've used a FAO model, the GUIDES model that tells us the class, and so we've excluded all of the areas that, according to this data set, were not suitable for hosting soybean. So after identifying and excluding all of the areas based upon the exclusion criteria, we have identified inclusion criteria. So the areas that have been included, well, essentially we've included all of the soil uses for agricultural use, and in particular we focused on 2 uses of soil which are important: forests and peatlands. This because these 2 soil uses are very rich in carbon. In forests, we have a large amount of carbon in soils, and in the forest biomass and in peatlands, we have high carbon organic soils. And so these are 2 hot spots in the study because we wanted to know how much carbon and GHG can be caused by the expansion of the oil crops. So amongst all soil uses, we considered these 2 in particular. One more step was the priority criteria in order to define the space dynamic of the expansion, in particular amongst all of the areas usable to determine the expansion of the crops. We've taken first the areas that are closest to those already cultivated with the target crop. So an expansion of soybean can be easily done in adjacent areas already cultivated with soybean, because there are the machinery, technology, and know-how and experience of the farmers who know how to cultivate that crop. And so it's easier to do a physical expansion. A second parameter was higher suitability. Using the data sets of the FAO GUIDES model, we've identified the most suitable areas for these crops, and the third criterion was closeness to roads, because we assume it's easier to cultivate areas near road infrastructures, because it's easier to get to the soil and work on it and transport the machinery and the crop. including during the distribution phase, rather than considering marginal areas that are far away. So as you can see, we've used existing data sets in this algorithm, including the IUCN, the landmark for indigenous lands, and the span guides, and they have been, you know, all used in this algorithm. Here you can see the distribution of the areas. The gray areas are the areas in which the crop is already cultivated. Take a look at the USA. The gray areas are those that are already occupied by soybean. And the green pixels are the areas that would have to be added to the existing gray areas in order to satisfy a replacement of 25% of palm oil with soybean in the US alone. Take a look at Argentina. Here we have yellow or red pixels. The yellow are added to the green and the red are added to all the other colors. And in particular, in Argentina, we have two crops, soybean and sunflower. And so here you can see that most of the USA and most of Argentina should be devoted to these crops in order to be able to satisfy a replacement of palm oil up to 100% in the case of Argentina, because we also have these red areas. So this is a first result that tells us where, in which areas, this expansion of the crops can be done in order to replace the palm oil crops. But interestingly, we wanted to know if there were forests in these areas and where. So this table shows the areas currently occupied by forests. So these are forests at risk for deforestation, and they are inside these areas identified for the expansion of oil crops. And every country has its own portion of forest. In Argentina, it goes up to 12 million hectares of forests at risk for deforestation for the expansion of the oil crops. And in total, we arrive at about 70 million hectares of forests that would be available for the production of these crops, and so potentially at risk for deforestation. But in fact, and by the way, here's another number at the bottom, 52 million hectares, because in this study, we've also done an analysis of the policies, so of the protection policies to protect existing forests in each of these countries. And we've assessed the probability of deforestation thanks to forest protection policies. For example, in countries like the USA, where there is a very strong and robust forest protection policy, we've assumed that this deforestation, these 8 million hectares, are unlikely. And so in this case, probably the forests will be protected and the areas will be expanded elsewhere. But in other countries, like for example, in Argentina or in Brazil, the deforestation the forest protection policies existing are weaker. And so we've assumed that there is a high risk of loss of forests in those countries. That is why you see 69.8, but this should be read as a 51.9 if we consider the forest protection policies in place. One more very interesting finding of the study, it was not our target, but you know, we've also had this finding. It is the risk of food security. A moment ago, I said that we mainly focused on forests and peatlands because we wanted to see the carbon content, but we considered all of the potential soil uses for the expansion of the crops. And in particular, if we take a look at the annual and perennial crops, we have realized that there are some agro-food productions that would equally be at risk for disappearance in case of expansion of the current oil crops. For example, in Brazil, as much as 56% of the current production of wheat would be at risk. And so we would lose that area, and that would be a food security risk. Currently, we have 2.2 million hectares of wheat cultivated in Brazil, and even 1.2, so 56% of these areas would be occupied by oil crops, losing this production of wheat, which is important for the food security of the country. We've seen the same thing for the production of bananas in Argentina. Up to 72% of the production of bananas in Argentina could be at risk as a result of the expansion of oilseed crops. And same thing for rice in the USA, 43% would be at risk. So 543,000 would be devoted to the production of the oil crops instead of the production of rice in the USA. Another fundamental point of our work was to understand the emissions related to the change in the use of soil, as well as the anthropogenic emissions, i.e. those generated across the supply chain of a product, in this case, 1 ton of the oils that we've seen. And so we've used, in this case, a number of approaches. So in order to estimate the loss of stocks of forest carbon, we refer to the data of the Forest Resource Assessment Report 2020 by the FAO, and we can see the CO2 per hectare in every hectare of forest. So on average, a forest in Malaysia, every hectare of forest in Malaysia contains 448 tons of CO2 in every hectare. So when I destroy 1 hectare of forest in Malaysia, I lose this amount of carbon, 448 tons of CO2. And in China, we have a lower level, on average 141 tons of CO2 equivalent for every hectare of forest destroyed in China. But when I destroy a forest, and if I want to be able to produce an oil crop, in this case, when I destroy the forest, all of this carbon is immediately released in the atmosphere. So I lose the carbon stock, it becomes CO2 emissions and goes to the atmosphere. However, to be more conservative, we have assumed that once the soil use is changed, so 1 hectare of forest is destroyed and an oil crop is planted, we have assumed that soil remains like that for 25 years. So as a matter of fact, we calculated annual emissions of equal to 1/25 of this carbon loss every year. And the other hotspot were the peatlands. And in this case, we've taken data from the literature. We have taken the recent 2019 IPCC report that give to us average values like peatlands in the tropical areas. I mean, if we drain them and use 1 hectare of peatland in the tropical areas, we lose 2 tons of carbon per hectare per year. In the temperate areas, 1.1, in the boreal areas, 0.2. But I must say that the forestry hotspot was very important, whereas the peatland areas shown by the algorithm as being suitable for the crops were fewer. We have calculated them, but they have a lesser impact on the global impact. But the other part of the emissions that we've calculated are the man-made one, the ones that they come from the entire cycle of production of the product. we've applied the life cycle assessment approach, the LCA. We've studied all that happens during the production cycle of the product. And in general, the life cycle assessment approach considers a number of stages like cultivation, processing, packaging, transport, as well as cooking. From the cradle to the grave. So we examine the whole life cycle of a product. However, in this study in particular, we only focused on cultivation. So we stopped at the farm gate because we wanted to calculate the emissions of GHG in the field, because we want to associate them to the change of use of the soil. So in this case, we've considered as inputs the raw materials, the seeds, the fertilizers, the transport to the field, and the fuel used for agriculture and agronomic cultivation, and pesticides and everything. So these are the main data, and our software multiplies them for obtaining a number of carbon footprint indicators, and they tell us what are the GHG tons per unit of product, so ton of oil, or per unit of cultivated area, so per hectare. And it tells us also the area required to produce a ton of oil, and this depends upon the yield, quite obviously. So here you can see some findings, and this shows the GHG emissions. These are tons of CO2 equivalents per hectare of cultivated surface. So here you can see the chart, and also per ton of oil produced. Interestingly, the blue bars are the emissions of GHG from the LCA, so the anthropogenic ones due to the field inputs, and the green ones are the emissions from deforestation that come from the land use change. So interestingly, the production of palm oil that is done mainly in Malaysia and Indonesia is the one that is most impactful as compared to the other oils, if we consider the surface used. And then we also have in Argentina very high, fairly high values, because here as well, the areas available for the expansion of the oil crops were mostly on forest areas, and the amount of carbon in the Argentina forest is very high. We've seen the numbers in Malaysia and Indonesia. We have large amounts of carbon per hectare of forest, and Argentina has very high values. China and India a bit less, so you can see that these green bars are shorter. But interestingly, these results are the opposite if we consider the emissions per ton of oil produced. So in this case, the palm oil produced in Malaysia and Indonesia is almost the least impactful of all, and this because palm oil has a very high yield per hectare. If we consider the same surface used, it can produce much more oil than all of the other oils. So quite clearly, these large impacts that we can see per unit of surface in the bottom chart are broken down by a large amount of product that comes from the surface unit, and so the impact is much lower per ton of oil, which is the unit considered. So amongst the least impactful, we have Argentina, which on top of using many forest surfaces that have a high content of carbon, have a low yield for soybean, and so the impact is very high per unit of soybean ton produced in Argentina. Another very interesting thing to be noted, as I said before, is this different color of the green bars, the intensity of the color. We have deep green bars, most especially Brazil and Argentina, and here the deforestation is considered to be highly likely because, like I said before, we have associated this analysis to an analysis of the forest protection policies. And in Brazil and Argentina, we've found very weak policies for the protection of forests. So it's very likely that there is this deforestation. But where you see less intense green, deforestation is less likely. For example, in Canada, it is likely, but with limitations, because it is possible to do deforestation in public areas. The speaker corrects herself, in private areas. So one part of the forests is not subject to deforestation because it is protected. In China and India, for example, we have deforestation that can happen, but with offsets. For every deforested hectare, you have to reforest 1 hectare elsewhere. So you can lose carbon in a mature carbon, but you also have a young forest. So in these cases, there is deforestation, but there are compensating measures. And in other countries, it is unlikely that there will be deforestation because they have very strong forest protection policies, like in the USA, Russia, and Ukraine. And importantly, can you see this green lattice for Malaysia and Indonesia for palm oil? Well, that's because in the deforestation-free, certified deforestation-free supply chains, this proportion of emissions is just not existing. So if the palm oil came from certified deforestation-free supply chains, we wouldn't have this proportion of emissions. And this is the lattice that you can see in the bars. So to conclude, and going back to our initial question, if it is better to use deforestation-free palm oil or replace palm oil with other edible plant oils, if we consider the environmental aspects, and in particular, if we consider the risk of deforestation and the total emissions, it is clear, based upon these findings, that using deforestation-free palm oil is the best solution because its impact is the least. This is the comparison in the 100% replacement scenario. So if you replace palm oil with other oils, you can see that the emissions could even increase, the GHG emissions, and we could have up to 52 million hectares of forest that could be at risk for deforestation. Instead, if we push for a supply chain that is a certified deforestation free, so if the entire production of palm oil became deforestation free, we would have a reduction of the emissions by 92%. So like I said, we would completely eliminate those lattice in the bars, and so we would only have the blue emissions in Malaysia and Indonesia, which are the ones used for the inputs used in the field. So in this case, the deforestation-free palm oil is the one that has lower anthropogenic emissions as compared to all of the other options. So with that, I'm done with my presentation. And quite obviously, if there are any questions, we will be glad to take your questions and answer. Thank you, Maria Vincenza. Yes, I have already answered some questions in the chat because they had to do with the availability of the video online. It's going to be uploaded to our YouTube channel. And also the initial part will be loaded. And then there is a question on the definition of deforestation free, i.e. what are the elements that allow the definition of deforestation free and how are controls done. Okay, so in this study, we did not deal with the control and how it is done. Rather, we assumed that this certification occurs in compliance with the principles. So there are different certification schemes. The most widely recognized globally is the RSPO, Roundtable for Sustainable Palm Oil. So you can look for the definitions, but deforestation free means that the plantation from which the oil comes is agricultural land. So over the last decades, there was no deforestation. But I say it again, in this study, we did not check the truthfulness of these schemes, which anyway are broadly recognized, but we've used other works already published in international magazines, and so we took it for granted that those principles are met. And so for us, that amount of oil is not attributable to deforestation. There's a question from Giovanni Cespa. Good morning, I'm a journalist. I was writing, but I will speak instead. Thank you for your presentation. I wanted to know what is the area currently used in Indonesia and Malaysia for the production of palm oil, because we've understood that 128 million hectares could be used elsewhere in the event of 100% replacement. And how many decades does it take to establish that the deforestation doesn't happen and that an area is deforestation free? And if we consider the importance of the forests and peatlands in the global continental meteorological system, because this has an impact on the general climate patterns. Well, you have many questions. As a matter of fact, I don't know if you can see it from the screen, and I also have other slides where you can see the surfaces currently occupied by all of the crops, and palm oil in Malaysia and Indonesia today occupies about 5 million hectares in Malaysia and 14 or 15 million hectares in Indonesia. So this is the comparison between the surfaces that you've seen and those that are currently occupied in these countries. These are the two main producing countries of palm oil, but these oils are also produced in lesser amounts in other areas of the world. But I mean, this is to answer in terms of the surface currently occupied in these countries from palm oil crops. Your next question was about the impact of forest land and peatlands on climate. Well, this is the purpose of the study. Understand that contribution to climate change of these change in land use, because forests are fundamental in the carbon cycle, and likewise peatlands. And so quite clearly, we have considered the effect on climate change when we have calculated the amount of carbon that we might lose. And then there are more effects that regulate the functioning of the terrestrial system, like, for example, biophysical effects and the color of the Earth's surface that changes depending upon whether it is occupied by peat or forest. But we have not considered these biophysical effects. Rather, we've only seen the carbon cycle emissions. I think I've answered all of your many questions. There are more questions on the chat. First one is, what is the criterion for choosing the countries for developing these scenarios? You said the main producers. Exactly. This is the criterion. And on this slide, you can see that these are the countries where there is more surface occupied by the three crops considered. And there's also a higher production. They account for 70 to 80% of the global production of those three oils. That's why we've selected the top three producing countries. Based upon the statistics, this is Faustat. So these are the globally available statistics. One question from Carlo Tornetta. We cannot hear. Maybe the speaker is muted. Okay, so I'll move on to one more question from the chat. I'm a mechanical engineer. Good morning. And I'm attending a master course on hydrogen. And in one lecture, I've learned one thing that impressed me. We are talking about hydrogenating plant oils, I mean, exhaust plant oils. And I have a concern. Does it mean that the world starts producing plant oil for hydrogenation, because this is very dangerous for the environment? Well, thank you. That's interesting. Yes, we are seeing several phenomena in the agro-food sector. And I don't want to talk about topics different from the ones that are relating to this webinar, but there are many trends relating to economic convenience of some countries, but quite clearly, well, the risks exist for various types of foods. So quite clearly, yes, we have to be careful, and we have to ensure the protection from these practices. But my personal answer is that you are right, we have to be careful. One question from the chat. In soybean crops, how can we separate the use for oil and the use for cereals as feedstock? Well, this is a very suitable technical question. We have considered this, and in particular with respect to soybean, because whereas from palm, you can only obtain palm oil, and the same from sunflower and rapeseed, but soybean can produce, flour, lecithin, and oil. And they can also be for different uses, for human consumption and for feedstocks, and also the other oils, like one portion of palm oil is for animals, and the same for rapeseed and sunflower, or for biodiesel. I mean, there are various uses. And I didn't show you for reasons of time, but in the algorithm that we have considered, we have also added factors coming from global averages of a different byproduct and different intended use. So based upon the averages of the recent years, we have been able to carve out the proportion for the consumption of oil and for food consumption. So we have also considered this. Thank you for your question, because you enabled us to clarify. One more question. with the recent change in Brazil in terms of deforestation, wouldn't it be possible that this phenomenon slows down in the country? And I'd like to also answer the following question that is about the more technical questions. I mean, no problem. You can write an email to the speaker if you want to have a more technical clarifications. Yes, sure. In terms of changes in the protection of forests, quite clearly, we will see, hopefully, in the future, a difference, meaning a reduction in deforestation. And with respect to sunflower, the main producing countries are Russia and Ukraine, and we know that over the last 2 years, the war is causing impacts on the production and distribution of produce. So we'll monitor the situation. We'll see what will happen in terms of availability of these products. So quite clearly, these results, these findings are a snapshot at the end of last year, and any forest protection policies or particular local conditions can have an additional impact on these dynamics. We expect more forest protection, and in Europe, for example, a recent regulation protects global forests, the EUDR. So we are sure that we can have traceability of all of the products that enter Europe, not just foods or agro-food products, but every type of product, so that they are deforestation free. Just think of poultry, meat, timber. So we are sure that they come from sustainable forestry management or deforestation-free certified areas. So we are sure that there's been no deforestation in the areas from where these products are coming. So hopefully these deforestation will slow down in the future. And then one more important thing is that since on palm oil, there's been lots of criticism. As I said at the beginning, we have focused on improving that supply chain. So paradoxically, this is the oil that had some problems in the past, but it is the one we are working most today to ensure a sustainable production and a deforestation-free supply chain. But as a matter of fact, this concept should be applied to the other oils as well. I mean, all of the other oils should come from deforestation-free supply chains, and you can imagine that all of these green parts could be eliminated if each of these oils came from certified protection, forest protection areas. Hopefully, this will be the case not only for palm oil, but in all the countries and for all of the oils where currently there is more deforestation. There are no more questions for now in the chat. I don't know if anyone else would like to say something. I'm not seeing hands up. So if there are no more questions, I think that we are done. Thank you for your participation, and thank you for the very interesting presentation. Thank you, Maria Vincenza. I don't know if you want to say something. Thank you all for attending the webinar. You can also have the English language scientific paper It is available for free on the website, and so no problem. And thank you so much for attending this webinar and listening to my presentation. Thank you and see you soon.